Okay, today's video is pretty simple. I'm doing the importance of annealing and the temperature variance that you will probably experience if you do a lot of 3D printing. The reason why this is important because you'll screw up tons of prints, things will happen, and you'll be like, what is going on? Why is the world ending? Why don't my prints work? Or why do they come out really crappy? Or why some prints are good or bad? And all sorts of things can happen. But I'd like to go over some stuff that's pretty annoying and I've experienced many times in the past, and it's something where you're sitting there fiddling with settings trying to fix it when in reality it's a hardware issue. These two prints that I have here in the view, they're the same print. Now, I left some of the base on this guy, but I just didn't really care about it because if you'll see here, look how squishy that is. Dang near just practically, you can crush this thing in your hand. It's like a sponge. Now, I have a worse example, and I'll bring it up. I'll flip this guy over so you can see the not front one print side. This dang near see-through sponge. See all that sponginess? Just crush and whatnot. Solid print comes out like a sponge. I mean, it probably looks like SpongeBob there, whatnot. Maybe if you're trying to have that effect or element in your printing, you might be able to take advantage of this. These parts here, these are separate parts made a long time ago. These are solid, hard, nice little products. This thing here, Swiss cheese. Here's another variant of it using a different material, but similar issue. Good annealing. At the bottom part, just get a hair bit up high. This stuff was all sponge too. It just tore right off. So getting back to this guy, you can see that sponge, but you can see down here, you're like, oh wow, that doesn't look that bad. Not that great, but it's not like up here. You can literally see this lovely line. What this here is, I stopped the print here. Well, when I say stopped, more like I came in at this point and said, okay, this was at 260 degrees with my printer's settings. I'll get into that here in a bit because it's important, but 260, and I lowered it to 240. Now you're sitting there saying, okay, so you lowered the temperature, doesn't anneal that great. Okay, that's not hard stuff to understand, but this printer, this 240, this was printed at 240. Right there. Why? This is way more solid than that or that. This annealed great. What happened here? This is a beautiful print. Does exactly what it does, has good structure, everything else, annealed wonderfully. What happened with this guy here? Same settings, all sorts of stuff same. The only thing different was the temperature. In this part, actually, the temperature was the same as this guy. Now, what I'll tell you is, I have an Ender 3. Obviously, Ender. Of course, I probably should say it that way. But this printer, it has the hot end extruder up here. Guy right over here, right by the camera. That piece, nowadays, they have like a silicone heat block. My one didn't have that. It has like some weird paper filament stuff. And that was its insulation on the heat block. That eventually kind of goes bad or goes away. So for whatever reason, whether it's your insulation stripped off, you switch out a head and use I would say like one of those hardened steel tips, aka you're not using brass, and you switch up a metal, you're going to be changing how that extruder heats. So same settings. This prints that. This wasn't because I exchanged the nozzle with like a different metal. This is because my heat block had insulation on it. Now, that insulation wasn't on purpose. I, a long time ago, screwed up a lot of stuff and had a print that went horribly, horribly wrong. Sometimes that's how genius works, is when you have something go horribly wrong, but you don't realize it went horribly right. And I'm used to being like, oh gosh, something has to look pretty for it to work. Not the case. So what happened was I had a carbon fiber filament and it basically just gunked up the whole head and just sealed it. Now, I still could extrude out and everything else, but the entire head was gunked up with, carbon fiber filament. That stuff acted actually as a really good insulating block. So I was printing this same type of print, like here, just like this guy here, at 220. I was actually printing all the way down to 210 and almost to 200 and getting this type of annealing. Beautiful, beautiful annealing. Now that I removed that stuff thinking, oh, I'm fixing my printer head, I'm cleaning it up, and now I get garbage. I didn't realize my head was actually being insulated by all that melted up plastic, and actually was improving my print quality. Now, just like in my old electronic engineering class when I was back in high school, we were taught you take your soldering iron pencil and you would put lead on it. We use our lead and you just melt it on there. You always leave the tip dirty. And what that did is it prevented the metal from oxidizing and actually preserved your tip. You can just heat it up and it falls right off. Same thing with these extruder heads. It works just the same way. You literally can just take the plastic, show you for example. You can take something like this and just literally melt it onto the thing. Now, you want to find one that's not going to fall off, because one of the things that I had happen is that I would have like this, I'll find some if I still have it here. Here we go. Like little chunks like this guy here. And I was cutting these off. Like, in other words, it was like a whole big chunk. And you'd have some stuff like this, and it'd be all built up. But as long as these weren't falling off, because as soon as they fell off, they were no longer insulating that heat block. And thus, I would go from something like this, or you have like a solid print, and then you would have some weird thing like this. Now this guy here, it's kind of hard to see because of the orange color, but this guy has the same effect that's going on with this guy. You can see that two different colorings from when it went from 260 to 240. However, this guy, same difference. You have the discoloring starting here. Right there's where you have it starting. And it becomes much squishier, weaker, where it's stuff down here much more sturdy. So from right here, what happened was the stuff that was on my printer head was a different type of plastic. It eventually melted off and fell onto the board, or fell off and went somewhere, and then basically allowed this area to not retain heat, so it cooled the print. Even though the printer thinks it's, hey, I'm at 260 degrees, 240, 230, whatever you had it set at, but that's not what's coming out the tip. And the thing is that you don't have a thermometer sitting on your hot extruder head or your nozzle, your old brass nozzle up there. You don't have a thermometer there, and that's not where it takes temperature. It takes the temperature at the heat block. You'll notice like a couple of wires coming from there. That's where it takes the temperature from. So it has a little thing inside the heat block that senses temperature. So that 260, 240, that's in the heat block, not what's coming out your tip. So if your tip isn't insulated or anything like that, it can drop 10, 15, 20 degrees. And like I'll show you on this guy here, as you can see, that is a 20 degree drop. Just 20 degrees. So when my insulation fell off, it did a very similar effect. Well, almost the exact same. You really can see in here that color differential. If you look right there, you can see it. So it dropped 20 degrees from the heat block to the nozzle. Now, one of the things I thought about doing is turning off the fan and seeing if that doesn't help with it. But they always have that lower print quality and all that stuff. But there's a lot of experimental settings you can do to change your print quality. But one of the things I find is I don't like to change settings as much as I like to change my hardware. So I'm ordering a new extruder head, hot extruder end, the whole thing, putting that on, and I'm also going to use one of those silicone heat blocks with it. Now, I'm going to keep this old guy here that I have set up now because I just re-put on carbon fiber. And if you want to know exactly which one I was using, it was this guy here. As you can see, I know it's upside down because how I have my camera. Woo! But there you go. That's the guy I'm using. And if you want to look at it, that's what it looks like. That stuff I had gunked up all on there and actually was insulating it well, held on perfectly through probably maybe like hundreds of prints until I physically cleaned it off. Even though it kind of got gooey and sticky, you got to think about it like this. Just because something like, great example, look at water. Water's a liquid. But if you put water around something, that water basically insulates it. It has to change temperature and all that stuff. Now, air is an awesome insulator. But it's the thing is, when you have a fan blowing over stuff, like especially over your metal's uninsulated at that point. That's why you put a rubber coating around something. It insulates the metal because the metal's a great conductor. Just loves to lose heat and electrons. It just gives that stuff away like it's nothing. So you're sitting here like, then you have that metal and a fan blowing over it, you're just losing heat like crazy through the metal. So you put something like a water around it, a liquid, sticky, silicone, whatever, you're now preventing that metal from losing tons and tons of heat. So you're no longer getting that 20-degree temperature drop. Now, just because I feel like it, I'll just show off of the thing because I like this carbon fiber stuff. This stuff was great looking. It comes out great with these prints. Now, this was an old design a long time ago. Like I said, I use these little refill guys. So the carbon fiber is a lot more solid, but that's why I just got to do this. Wow, this one was tight. It's been a while since I probably pulled this out. Yep, there you go. See, that's what this guy was here for. He's designed to put these little refill bottles in, because you see, refills. And it has the lead in there and all that stuff. Shake it, whatever. And I would have that slide in there. I probably shouldn't have made it so tight, but holds great. And have the little erasers. And I would have mechanical pencils. Right now I just have like pens sitting in them, and the pens would sit just like that. Great looking little design. Love how the carbon fiber looks when it prints. It makes this cool shiny like weird look. It's like kind of grainy or whatnot, but it's just beautiful to look at. It does not look like a PLA print. But then again, I really do also like the looks of these prints as well. They come out pretty cool looking material too, and these are the flexible filaments. And they're a lot more forgiving with the holes and entries. So this guy here, if you need something truly hard, I go with the carbon fiber PLA. It does a pretty good stuff. It's pretty rigid. It doesn't really break too easy or whatnot. It's pretty strong stuff. Unlike normal PLA, which is, for all intents and purposes, I consider garbage. If you're printing with that stuff, you're printing something just literally to see if the shape works. It's truly, for me, only for test printing. Just to see if where you have overhangs and so forth, and just throwaway material. It's nothing I would use for anything that's permanently set up. This guy, however, made of carbon fiber filament. I've had this thing for multiple years. It doesn't break down or anything. It still looks the same way I printed it originally. It's really nice stuff. Now, that being said, I was going to show off another one of these flexible filament guys. Another design when I had the hex rings and all that stuff in there. As you can see, a little bit different. A little less light on here. So a little less glare. And this guy here, he was made of the clear stuff. Well, I'm just showing this guy off because, once again, this was also made at 120. Or not 120, I mean 220. And I was very strong annealing, very strong material, did everything is right. But no change in the printer settings, and eventually I got spongy. So, once again, with printer stuff, it's important to know that your printer head or your extruder head can basically change everything with your filament. Filament, you think it's like, oh, this brand's crap or something, when reality is your printer has a problem and you're just not realizing it. So I would always suggest to kind of like, if you're seeing like this spongy stuff and you're printing at the temperatures that are supposed to be, even at the high end, it's supposed to have good annealing, and it's not, it's probably your extruder head. It's not like the filament itself. More than likely, it's your extruder head. And that's it for this video. Thanks for watching.